Hello, good people. This is Chapter 7 from your IBM SPSS book, sort of tutorial video or whatever for JASP. So it should be pretty straightforward if you're using SPSS, but it looks like there's a little bit of differences from the JASP that might cause some confusion. So here is the video for it. So as with all JASP, you got to open up some files. And so again, all these files should be available to you on Canvas. So let's do Chapter 7 stuff. And so the title of your Chapter 7 IBM SPSS says a one sample t-test. So you should look up here at the top left and you see t-tests. Click on that. You've got all these options. One that's very consistent with what the title is for Chapter 7 is a one sample t-test. We've got one sample t-test. So we go ahead and click on that. And so if you look over here toward the middle, we've got what the table looks like for a one sample t-test, but it's not populated yet with anything. So we got to move over our IQ variable and move it over here. So now we've got this t value of 75 and a degrees of freedom of 29 and p that's less than 0.01. And you start saying to yourself, well, this doesn't look like what IBM SPSS textbook looks like. So you're correct. So let's see what to do. So it's always good to just click on descriptives to see, make sure you're consistent with what your estimations are. So you got your descriptives, you got your N of 30, which is correct. You got your average of 110, which is consistent with the textbook. You got your standard deviation, standard error, also consistent with the book. So you're saying, all right, I got that right. And so what's interesting is that a one sample t-test, all you did was put in one sample data. So what you end up having is a average, but the software package doesn't know what it's comparing that average to. So we came up with an average of 110.733. But at this point, JASP doesn't know that you're comparing it to an average of 105. That's in your textbook, and you didn't put it in anywhere. So what's cool about JASP is that it allows you to put in whatever average mu variable that you want. So it calculated the average of the 110, that's what your data was, but it doesn't know what you're comparing it to. So what you can do over here is that this test value over here in the left middle, this test value is that we're comparing it to 105. And so if it's a 105 comparison, now all of a sudden it becomes consistent with what it is that we've been talking about here, this 3.9, and 3.9 is a t-value, and that's what your textbook now looks like. So now you know you're doing it right. There's a couple other things that are missing here. And so you should just click on effect sizes, because effect sizes are awesome. You should always be interpreting effect sizes. This is where stats really is going to be going. So you're still missing a few things, right? You're still missing the mean difference, and you're still missing a confidence interval. So if you look over here at this additional statistics, this location parameter, if you click on that, that's how you end up getting that mean difference of 5.733, which again is consistent with what's in your textbook. And you're still missing a confidence interval. Well, if you look over here, this location parameter, you click on this confidence interval, now you actually get the confidence interval here. And again, what does that mean? That confidence interval really is the mean difference between these two variables. So what's going on here, again, this is going to be part of your interpretation, and that's where most of your credit's going to be from this particular class, is how you interpret all this. So what's happening here is that your average for whatever this is, school, first grade, what are we talking about here? Superintendent Riverwalk School, talking about IQ. So we got Riverwalk School kids at a 110 average. We're comparing that to the 105 that we put in over here. And the mean difference between those two numbers is 5.7. So if you're just going to take 110 minus 0.7 minus the 105, that's how you get the mean difference. This confidence interval right here is saying how confident are you that the real difference lies between these two numbers. That's where we got this 2.7 and 8.7. So the real difference, I'm 95% confident that the real difference between these two groups of students is between a 2.7 and an 8.7 IQ points. So what does that tell you? That there's no zero in there, which is good. If there was a zero in there, that means that they're not different. So again, the whole point of a t-test is, are we going to say that we found statistically significant differences between groups? Well, I'm 95% confident that the real difference between these two groups is about a 3 to a 9. Okay, so that's still difference. You got a Cohen's d of 0.7. You should be able to interpret that to find out if that is a large effect or not. And you've got this p variable, this p value, that's p is less than 0.001. So what does that tell us? Again, go back to your textbook, understand null hypothesis testing. If you get a p less than 0.001, what does that mean? Are you rejecting the null? Are you retaining the null? And again, that null is the hypothesis of equality. So the null is basically saying, the null is saying that these two groups are the same. They're equal. Riverwalk school students are the same as all other students. That's the null. Do you retain or reject the null? Do you say that Riverwalk students are the same, or do you say that Riverwalk schools students are different? Tell me according to using statistics here, what do we do? Do we reject the null, or do we keep the null? That's what I'm looking for this kind of stuff. So hopefully this helps you figure out what you're supposed to be clicking on over here in JASP for Chapter 7. And happy interpreting. Well done.